Our topic for today is exponential functions, and you have experienced these from Algebra 1, from Algebra 2. We're just going to solidify some of the rules so that we can move on to logarithms past this point. First, we're going to talk about the properties of exponents, which are absolutely nothing new to you, but they are important. We have the product property that says if you have the same base, so b to the m times b to the n, we can simplify that by b to the m plus n. Our quotient, if we have b to the m divided by b to the n, that's going to equal b to the m minus n. The power rule, if we have b to the m raised to the nth power, then that can simplify to b to the m times n. The power of a product, meaning if I have two values raised to a power, I can distribute that. So this would be a to the m, b to the m. Same with a quotient. That will also distribute. Then some just other good things to know. A rational exponent so if I have something to a fraction exponent, rational just means fraction, this is going to be the same as the nth root of a to the m. Negative, if I have a to the negative n, that's going to equal 1 over a to the n. It doesn't make it negative, it makes it the reciprocal. And then last, hopefully you all know, but it's good to know, a zero power. Anything to the 0 is 1. So now we're going to use those rules to do just some simple simplifying. So we're going to simplify 81 to the 3/4. So I can rewrite this as 81 to the 1/4 cubed. Well, 81 to the 1/4 is just the 4th root of 81. So what times itself 4 times is 81? Well, that's going to be 3, because 3 times 3 is 9, so 9 times 9 is 81. 3 cubed, and 3 times 3 times 3 is 27. (36 to the 5/8), and I apologize if this is tough to see. 36 over 1/8 to the 1/8. So this is the 5/8, this is 1/8. So this is going to be 36 to the 5/8 minus 1/8 would be 4/8. Well, 4/8 is just 1/2. And to the 1/2 power is the same as the square root of 36, which is going to be 6. Next one we're going to do, we're going to have in parentheses 64 m to the 9th, n to the 6th, all of that raised to the 1/3. So the 1/3 is going to get distributed to each of them. So 64 to the 1/3, the cubic root of 64 is 4, because 4 times 4 is 16 times 4 is 64. M to the 9th to the 1/3 is going to be m cubed, because you're going to multiply the 9 and the 1/3, and n to the 6th to the 1/3 is going to be n squared. We'll do one more. C to the negative 3a over C to the 4a squared. You can do this in several different orders. I'm going to go ahead and distribute the squared first. So we're going to have C to the negative 6a over C to the 8a. Then we're going to subtract these powers. So C to the negative 6a, so it's going to be C to the negative 6a minus 8a, which is going to be negative 14a. And I'll write that as 1 over C to the 14a. Now we're going to look at exponential functions. So exponential functions are anything in the form b to the x. There can be a coefficient, but the important part is that the variable x is in the exponent. So there's two main categories for this. There's exponential growth and exponential decay. So graphically, exponential growth will look like this. Exponential decay is going to look like this. They both approach the x-axis. Here it approaches it at infinity, here at negative infinity. Exponential growth will occur if our b is greater than 1. So if you have 2 to the x, 10 to the x, something like that. Exponential decay will occur if x is positive, then if our b is between 0 and 1, it's going to be decay. And then if x is negative, if b is greater than 1. So if you have a 2 to the negative x, that's going to be exponential decay. In your supplies, in your papers that you have picked up, one of the papers that you need is this here. So there's a graphing for exponentials. So this is in logarithmic. There aren't logarithms. And then when you do the logarithms, we'll have a graphing logarithms. So here, y equals x squared is not an exponential function. The base is the x, not the exponent. So this is just our parabola. 2 to the x is an exponential function. So what we're going to do here is create a table of values. So I'm going to go from -2 to 3. We'll start with the positive ones. So 2 to the 0, anything to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 cubed is going to be 8. 2 to the -1 is going to be 1 over 2 to the 1, which is 1/2. 2 to the -2 is going to be 1 over 2 squared, or 1/4. So all exponentials, unless there's some transformation, is going to cross at the point 0, 1, because anything to the 0 is 1. Then for this next one, we're at 2, we're at 4, and then lastly up at 8. And then trailing backwards, -1 is at 1/2, and then we're at 1/4, and so on. So the numbers are just going to get smaller. So there is 2 to the x. 1/2 to the x, we'll go ahead and make another table of values. So if I have -2, -1, 0, 1, 2. So 1/2 to the 0 is 1, like everything. 1/2 to the 1 is 1/2. 1/2 squared is 1/4. 1/2 to the -1 is the reciprocal, so that's going to be 2, and this is going to be 4. So this graph still crosses at 0, 1. -1 is at 2, -2's at 4, and then on this end it approaches. So this one is exponential decay. The next three are just transformations of this graph here. So this first one, this is the same as being in parentheses, so this is going to go to the left 1. So we're just going to take all the points on this graph and move it to the left 1. So rather than being at 1, we're going to be negative, or 0, 1 is going to be at -1. The next one's going to be at 2. Next one's at 4. The one on the outside is going to move the graph up 1. You might find it helpful when moving it up and down to draw in a new horizontal asymptote. So now this graph is just going to be moved up 1. So we're going to cross here, here, here. Okay, the next one's going to be moved down 3, and we're shaded. So it's down 3, and then we're shading below. So I'm going to go ahead and do my horizontal asymptote at -3, and then graph off of that. So I just graph the 1, 2, and the 2, 4, and then just graph the rest of it. And then this one we are shading below. Okay, we'll finish up the rest of these graphs in a minute. The number E. So we're going to talk about the number E. This is what we call the growth constant. To generate it, E is equal to the limit as x goes to infinity of 1 plus 1 over x raised to the x. So what we can do to generate the number E is pick bigger and bigger values. And plug them in. So feel free to try this on your own. I'm going to plug in 1, 10, 100, 1,000, and let's do 100,000. Okay, so I picked bigger and bigger values. So this is 1 plus 1 over x to the x. So 1 plus 1 over 1 to the 1 is 2. Then we replace those 2 with 10. To get 2.593, then we get 2.705, then we get 2.717, this one's going to be 2.718, and that's where it tapers off. So E, which is the limit as x goes to infinity of 1 plus 1 over x to the x, is 2.718, is approximately. It is an irrational number, so it continues forever. On the calculator, okay, there's 2 locations for E. There's the e to the x, which is above the natural log, and then over here, there's the constant for pi, there's the constant for E. So if I just type in E, it gives me 2.71828. And so on, because that is the number of E. Okay, we're going to continue the graphing worksheet by graphing E to the x. So E to the x, I'm really just going to worry about 2 numbers. I'm going to worry about the 0, so E to the 0 is 0, and then E to the 1 is going to be about 2.718. So 0 is 1. 1 is 2.718. So I'm going to do 0, and I'm going to go somewhere in between the 2 and the 3, and then it's just going to be exponential growth. So those 2 points are the only points I really care about for right now. Now we have two transformations, a negative on the exponent and a negative outside. So inside and outside. This is going to be reflected in the y-axis. This is going to reflect in the x-axis. Okay, so in the y-axis, this whole thing is going to get flipped this way. So my graph is going to look like that. Around the x-axis, it's now going to get flipped over here. So it's now going to be at a negative, negative. So my graph is going to look like that. So the last thing that we're going to talk about is solving radical equations. And this is just going to fit in because eventually we're going to solve exponential equations, and I want you to tell the difference. So this is review. So let's say I have this radical equation. What we're going to do to solve this is to get rid of the radical. So I'm going to raise both sides to the 3. So that gets rid of the radical. Then I'll subtract the 41. Then I'm going to divide by a negative 7. When we do that, the inequality switches. So this is going to be x is less than or equal to 6. We'll do one more. So this is 2x minus 68 to the 2/3 is greater than or equal to 64. Again, we're going to be solving equations where the exponent is a variable, but when it's not a variable, we can just use our product or exponent rules to solve for this. So what I'm going to do here is I'm going to raise this whole thing to the reciprocal power 3/2. I need to do that on both sides. So the 2/3 and the 3/2 cancel. So on this side, I just have 2x minus 68 is greater than or equal to 64 to the 3/2. I'm just going to do as a side calculation. That's the same as 64 to the 1/2 cubed. 64 to the 1/2 is 8, because that's the same as the square root. And 8 cubed is 512. So this is 512. Then a few 2 steps. So 2x is greater than or equal to 580. So if I cut that in half, x is greater than or equal to 290. So you'll have a few questions on this in your homework, and it's just to emphasize the difference between if the exponent is a value versus the exponent being a variable. So that is exponential functions.